This is the hidden science of boxing power. It's not what you think. First, you need a solid foundation. All the power in your body comes from the ground up. It starts with a proper stance and footwork. This generates a ground reaction force. Think of it like a spring loading mechanism. Then there's the engine. As the hips rotate, it drives the kinetic chain reaction. Energy is transferred through the body from the hips to the shoulders to the arms, creating an explosive combination. The bridge is the core muscles. They stabilize the body and channel the force from the legs to the arms. Finally, the delivery. The shoulders and arms are the last part of the kinetic chain. They act like a whip cracking at the end of a rope. By the time the energy gets to the arms, it's traveling so fast that it doesn't even feel like you're moving. And that's how you get that one-punch knockout. When we think of knockout punches, we naturally focus on the fist. After all, it's the visible end of the line of force that ends up connecting with the other person's face. But in reality, the power of a punch doesn't begin at the fist. In fact, there are 4 distinct phases to the generation of explosive force in a punch that involve multiple different body parts working together in perfect harmony. Hi, if you're new here, this is where we take an in-depth look at the science behind everyday activities. Now let's go back to basics. How does a boxer generate such powerful punches? Well, just like walking or sprinting, it all begins with the foundation. A boxer stands with a slight bend in their knees and a slight lean forward, shifting their weight onto one leg more than the other. This is similar to a sprinter's stance just before takeoff, except the boxer's stance is wider and more stable. The most important part about this stance is the positioning of the feet, because the ground reaction force generated by the supporting leg during each step of a sprint is what propels the athlete forward. Similarly, when a boxer throws a punch, the force of the punch is actually generated by the reaction of the ground against the foot planted firmly on the ground. The foundation then drives the engine, which is the hips. When the boxer rotates their hips forward, they drive their leg and foot into the ground, generating a reaction force that travels up through the kinetic chain. This is like stepping off a curb where you plant your foot, then push off with the other leg. Except in boxing, the rotation of the hips is explosive. As the hips drive forward, the lead leg extends, driving the knee forward while maintaining its bend. The extended leg acts like a lever, transferring the rotational force from the hip to the foot and ultimately to the ground. This generates the initial force of the punch. But this force doesn't stop at the hips or the legs. It travels up the kinetic chain, which is made up of the torso, arms, and head. In order to transfer this force efficiently, the bridge must remain stable and resilient. And this is the role of the core muscles, particularly the erector spinae and the rectus abdominis. These muscles act like shock absorbers, absorbing the initial force generated by the hips and channeling it upwards. They also prevent the spine from bending and ensure the force is transferred smoothly and progressively along the kinetic chain. It's like pouring water from one container to another. If the containers aren't properly sealed, the water will spill. Similarly, if the core isn't strong enough, the force of the punch will be lost as the body twists and turns. Once the core has stabilized and channeled the force upwards, it reaches the shoulders. This is the final stage before the delivery phase. The shoulders act like a secondary lever, amplifying the force from the hips and redirecting it into the arm. The front shoulder drops as the back shoulder rises, creating a force vector pointing directly towards the target. At this point, the elbow is almost fully extended, storing potential energy like a wound-up spring. Finally, the arm delivers the punch, extending the fist to its maximum range of motion, releasing all the stored energy in an explosive manner. This sequential activation of the muscles in the kinetic chain is crucial for maximizing the efficiency and power of the punch. It's like a whip cracking. The stored energy in the whip snaps the tip forward, delivering a sudden and forceful impact. By comparison, a simultaneous release of energy from all the segments of the kinetic chain would dissipate the force over a larger area and result in less impact. So it's all about timing and coordination. The biomechanics of a powerful punch can be summarized in 3 key concepts. First, there's a progressive increase in force from the hips to the core, shoulders, and finally the arm. Second, The force is transferred sequentially through the kinetic chain, ensuring maximum efficiency and impact. And third, the entire sequence occurs in a fraction of a second, making the punch appear explosive and powerful. To put this into practice, let's break down the punch into its 4 phases and see how they work together. Phase 1. Foundation. As we've discussed, this involves the stance and footwork. Specifically, the weight-bearing leg should be planted firmly on the ground, with the toes pointing in the same direction as the shoulder facing the opponent. This provides a stable base for generating force. Phase 2. Engine. This involves rotating the hips explosively forward. To do this correctly, the hips should be rotated away from the target, creating an almost 90-degree angle between the trunk and the hips. The lead leg should extend, driving the knee forward, while the trailing leg remains bent, providing stability. The shoulders should remain level and not drop or twist during this phase. Phase 3. Bridge. During this phase, the core muscles play a vital role in stabilizing the spine and channeling the force upwards. This requires a combination of abdominal and back muscles, including the erector spinae and the rectus abdominis. The core should remain stable and resilient, acting like a bridge that transfers the force to the shoulders without twisting or bending. Phase 4. Delivery. This is the final stage of the punch where the shoulders and arm deliver the force to the target. As the hips rotate forward, the front shoulder should drop and the back shoulder rises, creating a force vector pointing towards the target. The elbow should be almost fully extended, storing potential energy. Finally, the fist extends rapidly to release this energy, delivering a powerful blow. Now we understand the individual phases of the punch, but how do they come together to form a powerful combination? The beauty of a boxer's skill lies in the seamless flow from one phase to the next. It's like a well-rehearsed dance where every movement builds on the previous one, culminating in a stunning finale. The rotation of the hips generates the force. The core stabilizes and channels it. The shoulders amplify and redirect it. And finally, the arm delivers the knockout blow. The timing and coordination of these movements are crucial for maximum impact. The entire sequence occurs in a fraction of a second, making the punch appear instantaneous and devastating. But don't be fooled by the seemingly simple action of a punch. There's a lot going on behind the scenes. From the placement of the feet to the rotation of the hips, the stabilization of the core and the delivery of the arm, each movement is carefully orchestrated to generate maximum force and impact. And while the mechanics of a punch may seem straightforward, putting it all together requires practice, precision, and power. That's why becoming a skilled boxer takes years of dedicated training and coaching. It's not enough to simply understand the mechanics of a punch. You need to put in the hours to develop the strength, agility, and coordination required to execute them effectively. The study of human movement is fascinating. Whether it's the graceful arc of a figure skater's jump or the powerful thrust of a boxer's punch, each movement tells a story of the incredible complexity and beauty of the human body in motion. From the intricate balance of forces to the seamless coordination of muscles and bones, there's a poetry to human movement that's both inspiring and humbling. As we continue to explore the hidden science behind everyday activities, we're reminded of the incredible capabilities of the human body. So keep moving, keep exploring, and keep discovering the wonders of human movement. Who knows what amazing things you might find. Thank you for watching. If you enjoyed this video, please consider subscribing and sharing it with others who might be interested in the hidden science behind everyday activities. Your support helps us continue to produce educational and entertaining content that sparks curiosity and inspires a love of learning. Until next time, stay curious and keep asking questions.